So today I actually thought about having some fun and I was thinking about doing some simulation. And I wanted to simulate a scenario whereby I could try to simulate like a real life environment where I have like people and then there are resources and then there's competition for those resources. And of course, there are dangers in the environment and things that are trying to harm you, just like we have in the real life. And I thought, how could I actually achieve this? And of course, I'm not a front end developer, so what I have here might look quite ugly to a lot of front end developers, and but that's really not the point. I just wanted to have fun. That's the point. That was the point of this video actually. So what I have here is maybe if I click on restart simulation, what I have here is I'm simulating people. And then people are moving around in a confined space. There is food, and of course, there are poisons that could kill people. And there are also like lions that could also eat people, more or less. So the green dots you see here are supposed to be food items. The red ones are supposed to be poisonous, and of course, the elliptical ones without tails are supposed to be lions. So the lions, of course, don't care about the food. They are only interested in eating people. The people themselves are only interested in eating food, but sometimes they mistakenly eat poison as well. So it happens that the ways the simulation is set up is that the people can get nourishment when they eat food. And that's also why you see over time they start to get big, but you also see some of them are still small. So the ones that are quite unfortunate that maybe they are eating food and then, of course, eating poison. So it's set up in such a way that if you eat food, of course, you get some benefits. Your strength increases, your speed increases, you also increase in size as well. And then, of course, if you eat poison, then the reverse happens. And if you have an encounter with a lion, it drastically reduces your strength. If you actually run into a lion, I think like 2 3 times or so, the person dies. And it's actually a fun thing, and I think you would also have fun just playing around with this. What I'm gonna do in the end is just maybe put this, just publish this on the internet and then provide a link, and then you feel free to play around with this in the end. So of course, there are some parameters that could be set here. So again, please don't mind the UI. It's messed up. I know. Just don't pay so much attention to the UI. So, but you could actually tweak some of the settings. So the number of food items we could have could go from 50 to 200. I will also provide the source code so you can bump up this number, go crazy however you want, just to see actually what happens. Because in the end, this is again similar to like chaos. Like having like a random, let's say, in the sense of say Monte Carlo simulation, if you're familiar with this. And because I did a lot of simulation topics while I was in the university, so that's also why I always find these topics quite interesting. But anyways, let's proceed. So let's assume there's an abundance of food, let's say 200, and then maybe I bump down the number of people to like 50. So they have like a 4 to 1 ratio of food, and then I can make like 10 lions more or less, and then maybe bring down the speed of the people to like 3, and then I can restart the simulation. So what you could actually see, which is of course what is intuitive, is that if you have more people and less food, then of course they would not thrive because there would be less resources for them to eat, more or less. And if you have a higher number of lions, then there is also a higher probability that people are going to get killed. If you also have a higher probability of poisonous substances in the environment, then of course people are also going to, there is a higher probability that people could get killed. Of course, this cannot really be likened to like a complete full real life scenarios anyways, but the point is just to be able to play around with some of this. And so you could actually, for example, vary, change or of course tweak these numbers like the people, food items, lions or whatever. And you also can, of course, if I provide the source code, you can tweak it, add more variables into the environment, and then you can in the end maybe collect the data and plot some charts, and then you can already start to try to see if there are actually real scenarios or likelihood, more or less, or likeness that you could get out of this whole thing to real life scenarios. So what's one thing we can see is maybe if I increase the number of lions to the max, which is 20, and then I restart the simulation. So you see that it gets, for example, it's starts at a certain speed, and then it bumps into a food item, and then like this one, it speeds up a little bit, and then if it also bumps into like the red ones, which happens to be poisonous, it reduces in size, it reduces in speed as well. Like you could see, this one, it just picked up speed because it had some food source. So that's really more or less it. If you look here also, you see that some of them are actually way bigger than others. The other are actually quite smaller, because again, this is purely random. So again, that's why I said you could liken this to Monte Carlo simulation. And again, I threw in some fancy stuff like these gears here, just for aesthetics. It's really not doing anything, just shows, oh, this simulation is on right now. And then of course, if I restart this, I have this kind of like a polar clock down here. But anyways, what I'm going to do now is maybe take you over to the source code, to the code editor, and then show you a little bit actually what or how I came about this. And then maybe you can also be able to play around with this and simulate some other fun thing. And of course, please feel free to tag me, and I will also want to see what you're able to do. So let's jump in. Let's look at the source code. So what I've done here is pretty straightforward. I've gone ahead to create a solid app. If you're not familiar with solid.js, it's a pretty much new framework, but it offers a lot more than you would get with, say, working with React or Angular. It promises to be much faster, and if you are familiar with working with React, it would not actually take you so much to get started with Solid. It's pretty straightforward, and it's also really fun to work with. Some of the APIs and hooks are pretty similar, if you ask me, and but with Solid.js, they are more or less thought of as signals. So um, you more or less create signals within your app, and then when any of those signals changes, your app gets to react to those changes. They get updated. Of course, those part of the DOM where that change has happened gets updated. And anyways, that's what I have here. I've created a quite pretty straightforward, simple, solid app. And here I've created a bunch of parameters that's going to help me to track certain parameters of the program. Again, here I've used this create signal. This would be more or less similar to what you have in React. I think this should be use effect. This should be it's pretty much similar to use effect if you're working with React. I don't know what I liken this to with Angular, but anyways. So I've created this bunch of parameters. So I have here like number of people, number of layers I have, the number of food, speed, etc., etc., some other attributes. And of course, I've added this signal here because I would like to give the user of the app the opportunity to decide if they want the app to have the possibility for the lions to starve over time if they don't eat or not. So you get the option to say, okay, I want lions to die over time if they've not eaten, or they should stay alive forever. And you get to play around with this and then decide the parameters that get to change in your simulation when you're working with it. And then I've created these stats here. So this is going to help me to track the number of this. Again, this also was helpful during debugging because again, I need to know what's actually happening here and stuff like that. So I need to know the number of deadlines, people, the number of weeks have passed because the simulation is set up in such a way that after a week, I take a row. I look at the lions again because what I do is during the course of the simulation, and over here, I have this function. This more or less is, of course, taking care of the button, like when you click the restart simulation button. So more or less, it sets this to true. Of course, it says the simulation starts to true, and then it resets the stats. So that's basically what it's doing, nothing fancy. And then at the setup in the root of the app, because this is more or less like everything is on a single page, so everything is within this container, as you can see over here. And then, of course, I added some inline styling. Again, I'm not a front-end developer, I would say, so don't mind the, the look and feel of the setup of the UI. Anyways, the most important thing is that we have all of these attributes. So here it's possible to have this input field. As you can see over here, this is a range. This is for the number of food items that are available. So if you can see here, the range goes from 50 to 200. You can tweak this to go from, you can actually go crazy here, whatever you would want to do more or less. And the same here, the number of people, you can bring this down or go up or whatever. And the same also goes for this one actually. And then speed as well. Um, if you, I mean, if you can actually go higher than 5, but again, it would actually move in an unrealistic fashion if you ask me. It becomes uninteresting. But the important thing, these are just for the stats. As you can see, the important thing actually is these components that I've created here. So, and I'm just gonna go ahead and open this. So this, I have created this with D3, if you're familiar with D3. So normally D3 is used for making plots. But what you can see here, of course, is that those components, those props are more or less passed into these components. And then down here, the actually interesting parts. So maybe we go down because again, this is just manipulate. This is basically just a canvas elements, and then like if you've ever worked with D3, of course, it ends up just manipulating SVG, canvas, and the rest. That's basically what it's doing. Pretty rudimentary, if you ask me. So, but maybe I go down to the simulation part, and then we can, or maybe we can actually start from up here. So what I've done is I create. Maybe we start down here. I'm hard coding the width and height. And this is, of course, shouldn't be the case. But again, like I said, and keeps, I'm also still repeating myself. Don't judge me so much in this regard because I'm not really a front end developer. But of course, our concern is just on the logic, more or less. So I'm creating an array of people, and this they are supposed to have these attributes. So they would have they would have speed, of course, in both in x and y components. The x and y components of their speed, because of course it's a vector, and we're working with the 2D space. If it were 3D, then we'd have a third component of a vector in the z-axis. So, but for now, we are focusing on these two, and we're also using this again to track their position. Again, we need the component both x and y, and then I'm adding this attribute here, v for speed, and more or less what I'm using this to do is to use this to still tweak to tweak these velocities. So when a person consumes poison, for example, I adjust this speed and then use this speed to tweak these ones. I don't tweak the position in the end because I don't want to adjust the trajectory. But again, like I said, feel free. If you get the source code from me, feel free to do whatever it is you would want to do. Go crazy. You trust me, you would not break anything. It's totally fine. So what I also realized was because I created food, a random array of food, and I'm giving them a value. So the idea was, of course, when you consume this food, it would add this amount of value to your strength. But I don't think I later followed through with this. I think I took a completely new trajectory. Anyways, I almost say again, as you can see over here, providing the x and y components of where this is situated in our simulation space. And then I'm adding this boolean here to determine if this food particle is actually food or poison. And then, but when I did it this way, I realized that most of the time I'm getting equal number of poison as food, and I didn't really like this. So I actually just did this further tweaking here. So I'm just looping through this again, and then over here I'm generating in an array of booleans, and how I'm generating that is of course with this function over here. So I get to specify the number that I want in my array, and of course the number of falses. So if I provide 103 for 30 for example, then it means I'm going to get an array of length 100, and out of this 100, 30 of them would be poison. That's just what it means. So if you see me using the function down here, it means the number of food, of course, will be the number of array of food. Of course, that's logical. And then the poison would be 30%. That's why you have 0.3 over here. So that's basically what we're doing here. So this is 30% of the 30% of the number of food would of course be poison. That's really the idea here. Okay, so let's continue. So now here I have the number of lions. Again, of course, this is pretty much to the people, so nothing fancy here. That's basically it. So what again? So I created this function. Basically, this is a function I use to calculate if a person is within a certain range of a lion, and if that's the case, then I use this function to calculate this and then decide on what to do. So this is just a help function that helps me to know when a person is within a certain distance from lion, which is danger in this case. And now I have this create effect. I think this should also be similar to use effect in React. Pretty the same API if you ask me, nothing so fancy. And then I'm using this prop more or less to decide when to start the simulation. So when you click the restart simulation, of course, I pass this prop from app in this case, which happens to be the root into this component, and then I start this simulation, nothing fancy. So again, I reset these values should in case they've changed when you change them from the settings for the simulation, and then I update it within this component. And then again, I recreate this because it's set up in such way that once you go to the site, the simulation just starts. Clicking the restart button simply restarts the simulation, but initially the simulation is always running. So when we do this, what we simply do is we recreate people, recreate the food, of course, adjust the falsies for when our food is poison or not, and then we recreate the layers, and then of course we start the simulation. That's it. We have here the animate function. This, of course, the most important function we have here, basically, because I'm calling our animate event loop here within a set interval of 20 milliseconds. So if you see over here, I'm using this 2D. Can look over here, see this is Canvas to context 2D that I'm actually using. And again, I borrowed a lot of this context from the D3 chart library in JavaScript that is offered by Observable. That's actually what I borrowed some one illustration they did actually, and then I modified this and adapted it for my own simulation. Anyways, so there's just a lot of manipulation here for our the items that we create, of course. So if you look here, for example, this is first looking through the food. If it is poison, I simply change the color to red, otherwise it stays green, and then is a fill. Because if you look over here, it's simply an ellipse. Each food item is an ellipse more or less. And then after that, I create the lions. So again, the same format, but more or less, I'm actually not using this anymore. This is, I wanted to actually add an image of a lion in the end, but I decided against this. But again, you can play around with this if you would want. So everything in my simulation is more or less elliptical, you know. So, but anyways, the important thing is that I have what I have here, of course, for the lions. Then I set up I copy, of course, this both the x and y components of the velocity from their components for each of the lions, and then I calculate the speed this way. Of course, if you're familiar with basic physics, this is one where we can calculate this from more or less. This will change in both x and y direction. The displacement in both x and y direction will be our speed because we are working in the 2D space. That's why we do it this way. Anyways, and then here we are only checking if this hits a wall, we simply just reverse the direction. Basically, that's all we are doing. And then we, of course, it's not stationary, so it has to move. Again, we do something like this to let this move. And then this would be the head. So for our lions, they're just ellipses. That's just all they are. And then for people, this is what you see that looks like tadpoles actually. So it's pretty the same concept that we have for lions, more or less. As you can see over here, when they bounce off the wall, for example, they swim, they have a head, and they also have a body and a tail, more or less. And they, of course, they can swim as well. So I simply added a couple more functions just to do some manipulations. So like over here, if you see the is range method that we had up there. So we check if this particular for each of the lions, we check if it is within a certain distance from a lion. um so if because this is for people, as you can see over here, we are looking through our people. So if they happen to be at a certain distance from our lion, we reduce their strength by 2. We don't kill them off immediately, we simply reduce their strength by 2. Remember that each person starts off with a strength of 10. So, but if this strength is, if this goes beyond zero, we simply remove that person from our game, and then we say the person is dead, and then we update our stats for the number of people that are dead. Pretty straightforward. And then the lion that happens to kill this person gains one strength. The strength simply increases by one. And actually, this is no longer this is redundant anyways, but that's also totally fine. Actually, I can get rid of this anyways because it's no longer necessary because um no, it is. No, it's we are within the purple loop, so that's totally fine. That's totally fine because we have lion over here. That's totally fine. Yeah, so again, other than that, it will have a body and a tail, and then it can swim basically. So when it swims, we now check as it swims, we check if it is within range, a certain range of a food item. If it is, we remove the food because it means it has eaten the food. And then it doesn't matter if it's food or poison, we simply remove it because it's being consumed. So now what we do is we check if that item was poison. So if it was poison, we reduce the velocity of the item for both the x and y, both the x and y components of the velocity by zero point 0.5, and then we reduce one from the strength of that person, and then we update because I just want to keep track of the number of poisons and food has been consumed just to know how random they are both in my simulation, more or less. And but if that's not the case, if this is what has happened, then we increase this, and then of course increase the person's strength, and again update our stats. That's pretty much what we do. So, but if we keep reducing, of course, at some point the speed would become really, really small. And then, so what we do more or less is if it's beyond a certain, if it goes below zero, or if the strength goes below zero or equal to zero, we remove the person because it means the person has died because the person can no longer function in our environment. And of course, we update the stats. Nothing fancy here. And then lastly, what we do is if the number of food items goes beyond five, we repopulate again. We add like 50. I think I should have just changed this to the number of food. We add like this number of food items into our game, and then we update that. In this case, I just assume that a week has passed, something like this. Of course, this would probably not be the best way to more or less to calculate this, but this is just to give you an idea what the thought process is here. And maybe I collapse this one so we have room. So, but again, if initially you said it that a lion can starve, so we simply check for all our lions, anyone that has a strength that is below 10, we remove it. No, we subtract the strength of each of our lions, and of course this should be after 1 week. So I think actually just move this logic away from here and put it in here and put it in here. So, but the point is that after 1 week, all our lions just lose 10 value of strength because they just assume that's just one way, more or less. We are currently checking our lions to make sure that, of course, they don't live forever. So after 1 week, they've been eating people all through the week, so they should just lose 10, which is not much if you ask me. And then for each of our lions, if any of them has a strength that's less than 2, we remove the lion and assume the lion has died, and then we update our stats. That's really basically all we do, and then we use set interval to call our simulation loop, and that's all. Pretty straightforward. So this was just one way, more or less. I just thought maybe I could just do something similar this way because the point is not more or less for you to or show this in any way, but the point is really to see that something like this is possible. So if, for example, you have certain thoughts about certain things, you might want to, of course, see how it actually works in life. Of course, it doesn't have to be something like this. Could be some actual thing, maybe in the field of physics. Because myself, I spent years in the university just doing simulation, basically in the field of quantum physics, and so that's also why I enjoy topics like this, anyways. But yeah, that's more or less what I thought I would show you, because I really think this is fun. I had fun building this actually. I worked on this over the weekend, on Sunday actually, and then I'm finalizing it today, which is Monday. And so that's one thing I think you could also check it out if things like this if things like this interest you. And of course, other than that, if you also have things maybe you think that's I could also maybe jump in to build something. Maybe there are topics that interest you, maybe in the area of simulation. Maybe we can do something actually quite more complex and also more fun and more interesting as well. Of course, yeah, feel free to reach out to me. I'm always open to, trust me, this simulation, and not just something like this actually, but like far more complicated stuff. um, they really interest me a lot, and I have a few days talking about them all day long. Anyways, I don't want to keep you. I want you to figure it out for yourselves, and of course, discover for yourself if something like this would interest you in any way. That will be all, guys. I would leave the link in the description so you can check it out later. You feel free to go to the internet page, play around with the simulation if you would want to. And of course, if you're interested in the source code, I will also share this so that those of us who would like to tinker about, please feel free to take the source code, play around with it, and let me know what you think. Anyway, guys, just the quick thing I wanted to show you, of course, feel free to play around with this, and then I'm looking forward to your feedback or your question. So I'm just going to go ahead and restart the simulation. So I'll click restart, and then everything is reset. And again, maybe I bump up the number of food to 200, number of people to 75 or so. That's totally fine for me. And number of lions around 15. That's fine. And then the speed of people to around 3. And then, of course, lions can starve if they don't eat. I think that's just fair. And then I restart the simulation. So now if you look around, if you look at this one, for example, each of them, if you just pay attention to one, maybe this one over here, once it touches the food item, as you can see, the speed actually increases. Like this one also, if you look at it, the speed increases all of a sudden. And yeah, that's also what's happening. Some of them that's eaten a lot, actually they grew like quite big in size. And the ones that haven't, or that have had quite little to eat, maybe due to just being unlucky, actually are much smaller, and they also move smaller. Sorry, they also move slower. And then over time, what you notice is that the food disappears because, of course, if they eat the food, and they also die. Some of them die because what happens is, of course, if you consume a certain amount of poison. So the point is, if there are much more unfriendly things in in the environment, people die more. But if there are more friendly stuff in the environment, of course, people thrive. So if you look here, we are already in the second week, and there are no dead lions yet, but there have been only 12 people, 13 people who died, even though there have been around 89, 90 poison food that has been consumed. So what this can already tell you, of course, is that of course this plays a part, but over time it's negligible. So because it gives people actually the option to, you know, suffer and then recoup over time. So but something like lions, of course, doesn't give people that chance. It drastically reduces the lifespan of people over time. So because if you look here, if we tweak this simulation a little bit, so let's increase the number of people. So now there's going to be a higher competition for food, and then we increase the number of lions as well. So there's going to be a higher amount of danger in the environment. And even if we increase the speed of people, this will really not do much. Of course, it's still going to do some, but you can really play the simulation around over time, and then maybe even generate a plot and try to make meaning out of this chaotic environment. But the point is that if we have more people competing for lesser amount of resources, and we have, of course, higher amounts of dangers in the environment, people are not going to thrive. So remember, we are already in the second week, and only 26 people have died. So, but with these new parameters, if we restart the simulation, what you're going to notice is that we would not get similar results like we did before. There's going to be more danger for people, and it's going to be harder for people to thrive. Anyways, that's all I wanted to show you. Of course, please feel free to play around with this and then let me know what you think. I'm really looking forward for your comments and what fun things you are able to do with this. Hit me up, of course, and yeah, let's have a conversation. With my current settings, as you can see over here, after bumping up these numbers, more or less increasing the number of dangers in the environment and of course providing less food. So just within a space of 2 weeks, as you can see, all the people have died off, and now we have only the lions roaming the place. So that's that's also quite interesting if you ask me. And but yeah, don't take my word for it. Play around with it yourselves and get back to me and let me know what you discovered by playing around with this.